Hey everyone, welcome. Today we're looking at a Leetcode problem called minimum operations to make array values equal to k. It sounds a bit complicated at first, but don't worry, we'll break it down step by step, nice and easy. Let's get started. So here's the official problem description. The main goal is, we have a list of numbers, called, and a target value. We want to make every single number in the list equal to using a specific kind of operation. We need to find the minimum number of operations to do this. If it's impossible, we should return -1. The tricky part is understanding the operation itself, which has a special condition about when you can use it. Let's look at that next. Okay, the operation seems a bit weird. You choose a number. But you can only use if you look at all the numbers in your current list that are strictly greater than, and if all of those numbers are the same value, then is valid. If few is valid, then you go through your list, find every number that's greater than, and set its value down to. That's the core mechanic we need to work with. Let's walk through the first example. We have 5, 2, 5, 4, 5, and want everything to be 2. First, are any numbers less than 2? Nope. Okay. Now what numbers are greater than 2? We have 5s and a 4. Let's try using h equals 4. Are all numbers strictly greater than 4 the same? Well, the only numbers greater than 4 are the 5s. And yes, they're all identical. So, h equals 4 is valid. We change all the 5s to 4s. Our list is now 4, 2, 4, 4, 4, 1, operation done. Now we want to get to 2. Let's try h equals 2. Are all numbers strictly greater than 2 identical? The numbers greater than 2 are all 4s. Yes, they're identical. So h equals 2 is valid. Change all 4s to 2s. The list becomes 2, 2, 2, 2, 2, 2. We did it. That took 2 operations. Now for the second example. 2, 1, 2. And we want everything to be 2. First check. Are there any numbers less than our target k, which is 2? Yes. There's a 1 in the list. The operation only lets us decrease numbers. We can never increase a number like 1 up to 2. So if we find any number smaller than k, it's impossible. We return -1 right away. Okay, so let's put the pieces together. First, that crucial check. If any number is less than k, game over, return -1. Because we can only lower numbers, not raise them. Now if all numbers are k or greater, our job is just to bring the ones bigger than k down. Think about the distinct values that are greater than k. Let's say the largest is v1, next is v2, down to vm, and then k. We can pick h equals v2. All numbers greater than h are just the v1s. They are identical, so we can change all v1s to v2. That's one operation. Now, v2 is the largest. We pick h equals v3. All numbers greater than h are now v2s. They are identical. Change them to v3. That's another operation. See the pattern? It seems like each unique number that starts out bigger than k needs exactly one operation to handle it. So the algorithm becomes pretty straightforward. First, we'll keep track of the unique numbers we find that are bigger than our target k. A is perfect for this because it automatically ignores duplicates. We loop through the input list. For each number, we first do that important check. Is it less than k? If yes, we stop and return -1. If the number is greater than k, we add it to our set. After we've looked at all the numbers in the list, the final answer is just, how many unique numbers did we put into our set? That count represents the number of operations needed. Alright, here's the Python code for that logic. It's pretty short. You can see we create an empty set first, then we loop through each in the input list. Inside the loop, we have our 2 checks, and finally we return the length, or size, of the set. Let's break down those loop parts just a bit more. So, inside the loop, for every single number, first, we ask, is this number smaller than our target k? If it is, we know it's impossible to reach the goal, so we immediately return -1, and we're done with the function. If the number is not smaller than k, we then ask, is this number greater than k? If it is, it's one of the numbers we need to eventually reduce. So we add it to our scene_greater_than_k set. Adding to a set automatically takes care of duplicates. If we add the same number multiple times, it only gets stored once. After the loop finishes checking every number in the input list, we just need the final result. Our set, scene_greater_than_k, now contains every unique number from the original list that was strictly greater than k. Based on our earlier logic, the number of operations needed is exactly the count of these unique numbers. So we return the length of the set using len. And that's it. How efficient is this? Well, we only loop through the input list nums one time. Let's say there are numbers in the list. Inside the loop, checking conditions and adding to a set usually takes constant time on average. So the total time is directly proportional to the number of elements. We call that big O of n, or order n time. Pretty good. What about memory? We're using a set to store the unique numbers greater than k. In the worst possible scenario, every number in the list could be unique and greater than k, so the space needed could also be up to order n in the worst case. If there aren't many unique numbers greater than k, it'll use less space. So let's quickly recap the main points. The absolute first thing to check is if any number in the list is smaller than the target k. If so, it's impossible, return -1. Otherwise, the problem boils down to figuring out how many distinct or unique numbers started out greater than k. A data structure is perfect for counting these unique values easily. The final answer is simply the size of that set. Hope that walkthrough made the problem clearer. If this explanation helped you out, feel free to hit the like button, subscribe for more Leetcode breakdowns, or leave a comment if you have any questions, or maybe a different way to solve it. And hey, if you're feeling extra generous, the Boba Fund is always appreciated. Keep practicing, keep coding, and I'll see you in the next video.